Welcome to Physics Paper 1, Section B. So we start with question number 14. Question number 14, instruction is answer all the question in this section in the spaces provided. Number 14, state Boyle's law. So the question here is asking you to state Boyle's law, that is the affirmative statement, because we have both the statement in terms of words and also statement in mathematical term. So Boyle's law states that the pressure of a fixed mass of a gas, is inversely proportional. It is inversely proportional to its volume, provided the temperature is kept constant. Provided the temperature is kept constant. That is, pressure is inversely proportional to volume. So that is the affirmative statement of Boyle's law. Question number B, we are told figure 5a, this one, shows a column of air of length 6 cm trapped by a mercury thread in a tube. Then figure B here shows the same tube in horizontal position. So this is a tube in vertical position, this is a tube in horizontal position. We have the mercury thread. At that point there is air column, the air trapped in between the base of the tube and the mercury thread. Here we don't have the mercury thread. So we go to the question. So the question is asking us to draw the mercury thread in figure 5b. We draw and show how it is going to be. So this question should be analyzed in terms of atmospheric pressure. So we know that atmospheric pressure is acting on the surface of the mercury thread. So when it is in a vertical position, the atmospheric pressure is a bit greater than when the tube is in horizontal position. When it is in horizontal position, atmospheric pressure is going to be acting, but at a low state. So in this case, because atmospheric pressure here is high, it pushes the mercury thread to go downwards the tube. But in this case, the mercury thread will not be pushed as hard as in diagram B here. So we expect like this distance to be more in diagram B. So the mercury thread will be somewhere here close to the end of the tube. That is where we are going to have the mercury thread. When you consider this distance, let me call it L2. Distance L2 should be greater than distance L1. Why? Because here atmospheric pressure is low. In this diagram, atmospheric pressure is high. So that is where you are going to draw the mercury thread. So you will have answered the question Roman 1. Then Roman 2, explain why the thread appears as in 14b Roman 1. Number 14b Roman 1 above is here. So explain the reason as to that. So he's saying the pressure on air column, is greater than the pressure on the air. Then So in air, total pressure is given by the atmospheric pressure plus pressure due to the mercury column, which can be written as PT. Total pressure is given by atmospheric pressure plus pressure due to the mercury column, whereby this is 8 of the air column. This one is the density of mercury, thread of mercury, and then gravitational acceleration or gravitational force. But that one is in M. But in B, pressure due to air column, that is due to air column, pressure on air column is equals to the atmospheric pressure. So in other words, the pressure in diagram A, pressure in diagram figure 5A is given by the atmospheric pressure acting on this mercury thread plus the pressure due to this column and this 8. So we have pressure due to this air column here and also atmospheric pressure. In this case, atmospheric pressure is equal to the pressure due to the air column. So because of that balance, that is also the reason why we have the thread being pushed to that side. So from there we move to question number C. State what is meant by absolute zero temperature. So from gas laws we have what we call absolute zero temperature. This is a temperature. This is a temperature at which the volume of an ideal gas, temperature at which the volume of an ideal gas is assumed to be zero. That is what we call absolute zero temperature. Then number next, a balloon contains hydrogen at a temperature of 2 degrees centigrade and a pressure of 6 millimeter mercury. So we have temperature 2 degrees centigrade, we have pressure 6 millimeter mercury. Determine the pressure in the balloon, that is pressure 1. So pressure 2 we don't have, but we are given temperature 2 is 18 degrees centigrade because the temperature, final temperature is 18 degrees centigrade. So when you get a question of this nature, the first thing is you work with SI unit, so you convert temperature to Kelvin. Like in this case, you are 273, you get 275 Kelvin. In this case, 273, you get 353 Kelvin. So from there, we know that from the relationship of pressure and temperature when volume is constant, we have from the pressure law, P1 over T1 is equals to P2 over T2, because that is P represents pressure and T the temperature. So from this formula substituting, we are going to have 6 millimeter mercury divided by temperature 1, which is 275, will be equal to pressure 2, which we don't know, divided by the final temperature attained. So after solving for pressure 2 in using the calculator, you are going to have pressure 2 is equals to 353 multiplied by 6 divided by 275, which is going to give you 7.702 millimeter mercury after rounding off. So that is the value for the final pressure attained. That is question number 14. Question 15. State 2 ways in which the centripetal force acting on a body of a mass m can be reduced. This is uniform circular motion, so you work on the radius. So two ways of which acting on a body can be reduced. So we are talking about the reduction of centripetal force. So first you reduce the speed of rotation. Reduce the speed of rotation. You also increase the radius. You make sure that the radius is increased. The radius from the center of the circular path. Increase the radius of the circular path. Increase the radius of the circular path. Number B, a stone of mass 0.5 kg tied on a string is whirled in a vertical plane along circular path of radius 2 meters and that its frequency is 2 cycles per second. Take pi as 3.142 to determine the velocity of the stone. Number Roman 2, tension in the string when the stone is at the topmost part of the circular path. So number 1, velocity of the stone. Are you going to work about this? We know that velocity is given by omega r. So from that formula, we also know we are given the mass. We also have the frequency and the radius. So we also know that velocity is given by 2 pi f. So this one is going to translate to 2 multiplied by pi, 3.142 multiplied by frequency. So that one gives us 25.136 meters per second from the calculator. That is the speed of the stone. Number B, we are asked to find the tension on the string. And we know that in a vertical circle, we know that at the topmost point here, tension T will be given by mv squared over r minus the weight of the body, which is equals to mg. We are given the mass. We also know the velocity because already we have got the velocity from above here, B Roman 1 above. So we have T is equals to mass 0.5 multiplied by 25.136 squared divided by radius r, which is 2 meters. Then we subtract mass multiplied by gravitational force. So after calculation, you are going to get 152.955 Newton. Or you round off to the nearest point, you have 153 Newton, because you asked about the tension, which is force. So SI unit is Newton. State with the reason how the tension in the string changes as the stone gets to the bottom of the circular path. So in this case, if the stone is going to get to this point here, you find that the tension has increased because it is at the lower side here. So one thing is tension increases at the bottom. Because it is acting in opposite direction. To the weight. Because it is acting in opposite direction to that of weight of the body. So from there we go to number 16. This is question from floating and singing. Figure shows a cube of mass 2 kg and size 5 cm fully immersed in the liquid of density 0.8 gram per centimeter cube. The cube is balanced by a stone of mass m. Given the gravitational field strength G is 10 Newton per meter, determine upthrust acting on the tube, apparent weight, the weight of the stone. So number 1, we know that upthrust is given by the density, gravity multiplied by the volume. So in this case, you are going to have we are given the value of G. We also given density. We also given the measurements. The measurement here for us to be able to determine the weight of the stone. Number 17b. A well-lagged calorimeter contains a liquid of mass 200 grams at a temperature of 10 degrees centigrade. An electric heater rated 80 watts is used to heat the liquid. The figure below shows a graph of temperature against time for the liquid. So this is a graph of temperature in degrees centigrade against time in minutes for the heating process. So the first question is, from the graph determine the boiling point of the liquid. So we are required to use the graph. So if you are required to use the graph, as you can see here, the heating started from the liquid was initially at 10 degrees centigrade. Then it absorbs heat energy as the time progressed until we reached a boiling point here. So using your ruler, just extrapolate this point backwards so that you can be able to read. From that position. In this case, you have in one small division. One small division is the same as 1 degree centigrade. So in this case, it will be this is 100. One division, 1, 2, 3, 4, 5. So 5 division is equivalent to 10 degrees centigrade. So 1 division is equivalent to 10 divided by 5, which is 2 degrees centigrade. So in this case, from 100 we have covered 2 small divisions, so that one will be 100 plus 2 multiplied by 2 degrees centigrade, which is going to be 100 degrees centigrade plus 4 degrees centigrade. You get 104 degrees centigrade. But you have to show how you have read that value from the graph. So our value here is 104 degrees centigrade. So you answer here, that is 104 degrees centigrade. So you don't just write 104 degrees centigrade. You should show from the graph how you have been able to read that as per the scale provided. Next question. Calculate the quantity of heat given out by the heater between time t1 and 1 minute and the time t 4.5 minutes. So between 1 and 4 minutes. So between time t1 is here. So using your ruler, you can be able to read this point here. And then 4.5, you also have a perpendicular bisector there. Then those 2 points you read from the graph where the 2 lines have intersected. That is the value 1, and the other value, read that value. This one will be your temperature 1, this one will be your temperature 2. So from what we can be able to read from the graph here, that is what you are going to use. We get the temperature difference because we must get the temperature difference. So our value here, my value here is 28 degrees, and here I have 94 degrees centigrade. So from here we are going to have Q, that is the quantity of heat is given by PT, whereby P is the power. The power we are given is 80 watts. So this one will be equal to 80 multiplied by the time taken. The time difference is 4.5 minus 1, which is going to give you 3.5. So we are going to get 80 multiplied by 3.5, but remember time should be in seconds. You multiply by 60 to change into seconds, so this one is going to give you 16,800 joules of energy. Then from there we move to number C. Based on Roman 2b above, determine the temperature change between time t1 and time t4.5. So in this case, the change in temperature will be equal to theta 2 minus theta 1, where theta represents temperature. That one is going to be 94 minus what we read from the graph, 94 minus this value here, 28 degrees centigrade. It's going to give you 66 degrees centigrade. If you do the wrong graph, you read the value from the graph directly using a pencil rather than my biro pen here, to get this value as the 30 degrees centigrade. So that is the temperature. Then number Roman 2, we are supposed to find the heat capacity. So we know Q is given by MC, change in temperature, where C is a specific heat capacity. So C is going to be equal to, we have the quantity of heat already, we have found here. So that one is going to give us 16,800 joules divided by 0.2 multiplied by 66, the temperature that we have got. So you get 1312 joules per kg per Kelvin. And from there we proceed to D. 2 grams of vapor was collected and from the liquid between time T5.4 and T5.6.3. Determine the specific heat of vaporization of the liquid. So change in temperature was 6.3. Change in time minus 5.3, which is going to give you 0.9 minutes. Then you multiply by 60 to get time in seconds. So from that we know that L, latent heat of vaporization, is given by the PT divided by the mass of the liquid. So this one is going to give you 54 multiplied by 80 divided by 0.02. So you get 2.16 times 10 by joules per kg. Last question is number 18. So you follow the working.